So let's talk about the different parts of the brain and that they do. Parts of the brain are functionalized for different purposes, they do different things, which is why damage to different parts of the brain has different effects. It's why when you look at an fMRI scanner or PET scan or something that records neural activity, you could figure out based on the location of the activity that's going on. So, the first thing to realize is I'm talking about the brain, but I'm being more precious and more inclusive if I'm talking about the brain and parts of the spinal cord. So, you don't need your brain for everything. There are certain activities we do that can happen without a brain, like sucking in newborns or pulling your limb back to withdraw from pain or vomiting. But for everything else we talk about in this course, we'll really be talking about the brain. So, some of the structures of the brain that are highly relevant are called subcortical, which means they are below the cortex, which means they are in the center of the brain. This includes part of the brain like the medulla, which controls certain automatic function, like your heart rate, your blood pressure, swallowing, and so on. It includes the cerebellum, which is involved in body balance and muscle coordination. It contains about 50 billion neurons, so this isn't small potatoes. The hypothalamus, which is involved in feeding and sex and thirst and different appetites. We are going to talk about emotions or visceral desires. We'll return to whose parts of the brain, but for the aspects of psychology that are distinctive for us, that make us human, we are mostly focused on the outer layer, the cerebral cortex. So, the cerebral cortex, it is all crumpled up. If you were to take a brain, put out the cortex and straighten it out, like you are removing a rock you got from the trunk of your car, and you have to straighten it out. It's about 2 feet square, so it's a lot of crumpling to get it in. It's about 3 millimeters thick. This is where the action is. This is there at least for the things I am interested in. This is where it takes place. Is where reasoning and language and complex perception comes from. Fish don't have any cerebral cortex. Reptiles and birds have a little bit, but primates, including humans, have a lot. When you look at the cortex, you'll see it has two halves. It has a left half and a right half. For each of these halves, then you look at it, you can demark the brain, the cortex into different lobes. This is going from your forehead and swooping to the back. You have the frontal lobe, conveniently enough on the front, the parietal lobe, the occipital lobe, and the temporal lobe. Each of these lobes with different things which they'll talk about in a bit. Another thing about the cortex, thought this is super interesting, is that it includes maps. That I mean by this is it includes topographical maps. There are two things that are close together in the brain are similarly close together in the body. So this motor area there, if you were to shock parts of the brain, parts of the body will twitch accordingly. Just like you expect the middle finger is close to the thumb. This is closer to elbow if it's close in the real world and your body is close to the brain. And this is primarily somatosensory area, which is the sense organs. There, if you have somebody in the operating table and you talk to people, they would experience things. They might experience a sound or a flash of light or a touch. In fact, in the occipital lobe, you have a map for vision, and in the temporal lobe, you have a map for sound. That's really cool. I said the map is topographical, but the size of the brain areas don't correspond to the size of the actual body areas, but rather to the extent to which there is motor or sensory function. So artists have drawn pictures of people if their body was proportional to the extent that their brain was. You'd see the trunk or the body is whole lot of sensation. there's much more sensation going on in your hand than in your wall. But even food, the bag is physically apart. So, part of the context is with projection areas, but less than a quarter of the cortex contains projection areas. As I said, the rest is involved with the cool stuff, with language, with resonate, with moral thoughts, and so on. Then the question comes in: how do we know this? How do we know that parts of the brain do that? That parts of the brain are involved and why? There's different answer. So one answer is we can scan of the brain. We can use MRI, which is a high frequency magnetic field, to look at the activity of the brain that parts and activity when people do different things. We can also look at so-called natural experiments. Then people have tumors or strokes or motorcycle accidents in damaged part of your brain, and they can ask the question that damage to which parts of the brain correspond to damage to which functions. Through these different methods, we are learning about the different parts of the brain and that they do. We could talk about some central specific things that can go wrong due to brain damage or stroke or trauma. So, for instance, there apraxia. Apraxia is problems of action. So you are unable to do an action like waving goodbye or picking up before or can bring some food to your mouth. You are not paralyzed. You can make the movements if you have to, but you can coordinate these basic movements into complex actions. This agnosia. Agnosia is a disorder of perception, and they are not like you can see but you can recognize. Some is called physic blindness. People of various forms of agnosia can describe a picture in terms of its part, but can recognize the objects that are being depicted. Next, a form of visual agnosia. There are also specific prosopagnosia. There you can recognize faces. Oliver Sacks wrote a wonderful book many years ago called The Man Who Mistook His Wife for a Hat. This was a series of profiles of people who had surprising neurological disorders, and the title case of the book was A Man Who Actually Had Such an Inability to Recognize Faces he couldn't distinguish his wife face from that of a hat. Milder forms of prosopagnosia which some people suffer from, and to be honest, I got a little bit of some terrible faces. Is that you could recognize faces as faces, but you can't recognize whose face they are, and it's very hard for you to recognize people. With problems of sensory neglect, you get disorders that block out one part of the world. You might have damage to parts of your brain that will block out the left side of the world. It's not just the sort of physical things. Then you ask somebody this disorder to draw clock, for instance. They put all the numbers from 1 to 20 on the right side of the clock. Is as they do think on the left side of the world again. So maybe it's not even a sensory problems, but the attention problems. With aphasia, which refers to disorders of language. Some forms of aphasia are expressive, like a Broca's aphasia. There you can really speak. A famous case of somebody who can only use the word 10 words and 10, 10, 10, but could say anything else. Or then there's something that's called receptive aphasia. There you can speak a thought that you say doesn't make much sense, but also you have a terrible time understanding other people. Then there's a sort of other disorders. There's disorder which we talk about the regard to Phineas Gage and various forms of it. That damage to your brain is debatable whether this is true Phineas Gage, but there are other cases that is much more clear. Cause you to lose your moral sense, your sense of right and wrong, your ability to control yourself, to restrain yourself, perhaps your conscience. We can see that anyone who argue that the mind isn't the brain would be hard-pressed to explain why damage to the brain seems to affect some very intimate and very important aspects of ourselves.